So this is the last section of Unit 3. Um, it is a pretty long section and has just more ways to manipulate delta H. So what you see in this thermochemistry unit is that there's just a significant amount of formulas, a significant amount of ways to do problem solving. So you should assume that the assessment will be mostly problem solving. So we're going to go into the last item here, and you're going to start to see some terms you've probably not seen before, and the the terms, the vocabulary. Trying to keep all that straight is really important. So, understanding that exothermic has a negative sign is critical, but you can't do anything with these formulas if you don't understand what those variables are. So the first new variable we're going to introduce is entropy. And so when you think of entropy, um, entropy is disorder. Entropy is randomness. And so it says entropy, which we use an S as our abbreviation. So you're going to see things like S or delta S. And so entropy, or S, is going to be a measure of disorder. So a measure of disorder or a measure of randomness. So disorder, my S didn't come out very well. Let's try that again. So there you go. Disorder or randomness. Okay, so what we should say about randomness at this point is that chemistry likes things that are random. The world and the way nature works is that things tend to go towards randomness, towards disorder. And so if we have an increase in randomness or an increase in disorder, then that leads us to the idea that this is something that would likely occur. And so one of the things we're going to do in this last section is we're going to look at a reaction. We're going to say, is that going to happen? Or is that reaction very difficult or very unlikely to ever occur? So that takes us to our second term, which is spontaneity or spontaneous. So spontaneous means that it just happens organically. It happens without being forced. And so a spontaneous person is somebody who comes up with ideas just randomly. They're not planned out. They come up with ideas. They might be the person that you know who comes up with a cool thing to do on the weekend, and they just came up with it. And so those are spontaneous people. They come up with things without the need for a lot of planning. So a spontaneous chemical change is something that's going to happen without a bunch of work. And so work is basically in science is meaning that you're adding some sort of action or influence for that to happen. So spontaneous change is going to happen without the need to do work, or it's just going to happen on its own. So here's an example. Ice cube melts when added to a glass of water, or an iron nail will rust when exposed to air that has moisture or humidity in it. So if you have your ice cube and you drop it just onto the table, don't even have to put it in a glass of water, then after a bit of time, your ice cube is going to turn into like a little puddle, right? And so that happens on its own. So you didn't do anything. All you did is get your ice cube out, and you just slapped your ice cube on the table and you walked away, and you came back and you had a puzzle, not a puzzle, a puddle, and that happened on its own. And so that was spontaneous. What's not spontaneous is we take that same puddle and it turns itself back into an ice cube. Right? Like that is not going to happen. So that's not spontaneous. And so the spontaneous one is the thing that happens on its own, and then going back into the ice cube, it's going back to the cube. That takes some effort, like a freezer. And so that's not spontaneous. So not spontaneous, next definition, is one that does not, it cannot take place in a system left to itself, meaning if you just leave it alone, it just doesn't happen. So not spontaneous, that's something that does not happen on its own. So if a process is spontaneous, then the reverse, and I kind of showed you that picture above, the reverse process. So if you go one way, it's spontaneous, the other way is not spontaneous, or vice versa. And so if you look at the ice cube up here, if we went one direction, it would be spontaneous. But then if we went and just drew the arrow the other way like this, that's the not spontaneous. So they're just two sides of a coin. So now the term spontaneous signifies nothing about speed or how fast it happens. So something could be happening spontaneously, but it could take hours or years, but it would still be spontaneous because it is happening. So that says both endo and exothermic can be spontaneous, so that will not determine spontaneity. You actually have to look at the states of matter or some charts. So here's another example. Evaporation is spontaneous and endothermic, where dissolving sodium hydroxide pellets in water is spontaneous and exothermic. So we cannot use the concept of endo and exothermic to determine our value for S. All right, so just some definitional stuff here about our new terms. So we want to take away spontaneity or spontaneous and not spontaneous, and entropy. These are the two new terms we're looking at here. Okay. Some examples here. Identify each of the following processes as spontaneous or not spontaneous, meaning, are these things going to happen on their own, or do they need a little bit of bump? Do they need some energy? Do they need us to do something? So go ahead and run through them, pause the video, and then identify if you think that they're going to be spontaneous, happen on their own, or if these are not spontaneous, meaning that they have to have some sort of influence in order to occur. All right, first one. Vinegar reacts with baking soda. So vinegar, sodium bicarbonate, acetic acid, and the baking soda to create some carbon dioxide gas. All right, so if you've ever put any vinegar on baking soda, if you've done the volcano thing, if you've done any of that, you'll know that this happens automatically. You touch the vinegar to the baking soda, it starts to fizz, it starts to bubble. You might, you can clean your drains out with this. You can, and actually vinegar and baking soda is a very good cleaner. And so if you haven't seen this, you have no idea. But this is going to be spontaneous because it's going to just happen automatically. So that's something that happens on its own. You just have to, touch the vinegar basically to the baking soda, and it will start to bubble. And so then the CO2 is created on contact. Okay, second one. Boiling of water, here's the key thing, at 65 degrees Celsius. Water doesn't boil at 65 degrees Celsius. It boils at 100 degrees Celsius. So this is not spontaneous because water boils at 100 degrees Celsius, which means for this to happen, we would have to actually do something weird. So we could make it happen, but we'd have to change the pressure. We'd have to put it into some sort of device that changes the pressure, and then that could occur. But that's not going to occur on its own. You're going to have to do some work. Otherwise, it's just not going to happen. Does wood decay if you just bury it in the ground? Yes, you should probably know that that just sort of happens. So decay is generally, spontaneous. So things decay, and so things break down. So that's just going to happen on its own. Just don't have to do anything. um, so this is saying, do we make sodium metal and chlorine gas from salt water? Because that's what that is. Sodium chloride is salt water. And thank goodness that this is not spontaneous. Salt is going to turn into salt water, but salt water is not, that's going to turn into salt water, but that salt water is not poisonous gas and highly reactive metal. And so salt water, what salt water is that salt water is little sodium ions and little chlorine ions floating around. If you have chunks of sodium metal, they will catch on fire and fizz and pop and explode in water or any kind of contact with humidity. And chlorine gas is poisonous, so this is a poison. And so if you're making salt water, you're not making a poison, thank goodness, or we would, be in a bad way. And so just kind of be careful when you're kind of thinking through that. So, and last one, ionization of HCl when it dissolves in water. And you probably don't know this one. It's probably the one that the last two are kind of tricky. This is spontaneous. Not that I think you would understand this, but basically all acids, what an acid is, an acid, which hydrochloric is a pretty significant acid. Acids are things that break into hydrogen ions when they're in water. So that's literally the definition of an acid, is that an acid makes hydrogen in water. If it doesn't make hydrogen, not an acid. So anyway, key thing here, do they happen on their own, spontaneous, or do they